Hello my dear students, welcome to my chemistry class. In this video, I have discussed question number 106 to 118 of set G5. Let us start. Question number 106. Identify the correct statements from the following. A. CO2 gas is used as refrigerant for ice cream and frozen food. B. The structure of C60 contains 12 6-carbon rings and 20 5-carbon rings. C. ZSM5, a type of zeolite, is used to convert alcohols into gasoline. D. Carbon monoxide gas is colorless and odorless. Option 1, A and C only. Option 2, B and C only. Option 3, C and D only. And option 4, A, B and C only. Solid carbon dioxide is a refrigerant, but not the carbon dioxide gas. Therefore, statement A will be out of choice. Fullerene contains 26 membered rings and 12 5-membered rings. Therefore, it will also be out of choice. ZSM5 is a synthetic crystalline zeolite and used to convert alcohols to gasoline. And we know carbon monoxide is colorless and odorless gas. Therefore, the correct statements are C and D. So the right option is option number 3 here. Question number 107. The correct option for free expansion of an ideal gas under adiabatic condition is option number 1, Q equals to 0, delta less than 0 and W greater than 0. Option number 2, Q less than 0, delta equals to 0 and W equals to 0. Option number 3, Q greater than 0, delta greater than 0 and W greater than 0. Option 4, Q equals to 0, delta equals to 0 and W equals to 0. For an adiabatic system, Q equals to 0, and for free expansion W equals to minus P external into del. We know for free expansion of ideal gas, P external equals to 0. Therefore, W equals to 0 into del V. That means W equals to ultimately becomes 0. Change of internal energy del U equals to Q plus W equals to, therefore 0 plus 0 equals to 0. As delta U equals to 0, delta should be 0. Therefore, the option 4 is the right answer. Question number 108. Which of the following oxoacid of sulfur has peroxide leakage? Option 1, sulfuric acid. Option 2, peroxodisulfuric acid. Option 3, pyrosulfuric acid. And option 4, sulfurous acid. Look at the structures of 4 acids given in the 4 options. This is sulfuric acid, H2SO4. There is no peroxide linkage. This is H2H2O8. That means peroxodisulfuric acid. There is one peroxide bond. This is H2H2O7. Pyrosulfuric acid. There is also no peroxide linkage. Again, in H2SO3, that means sulfurous acid, there is also no peroxide linkage. In H2H2O8, this is the peroxide linkage. this peroxide. Therefore, this is the right answer. That means option 2 is the right answer. Question number 109. Identify compound X in the following sequence of reactions. When toluene reacts with chlorine in presence of light, toluene is converted to benzyl chloride, which on hydrolysis gives rise to the product benzaldehyde. Benzyl chloride when reacts with H2O the intermediate compound is formed. One water molecule is eliminated from here. This rise to the product benzaldehyde. Therefore, X is equal to CCH5 CHCl2, that is benzyl chloride. Therefore, the correct option is option number 2. That means this is the right option. Question number 110. The number of protons, neutrons and electrons in lutetium 71, 175 respectively are option 1 104, 71, 71, option 2 71, 71, 104, option 3 175, 104, 71, and option 4 71, 104 and 71. This denotes the number of proton and number of electron, and this denotes neutron plus proton. There is mass number and the atomic number. Now, therefore, number of proton equals to 71, number of neutron equals to 175, that is number of neutron plus proton minus number of proton, that means 71, equals to 104. Number of proton equals to 71 equals to number of electron. Therefore, the correct option this is the right option. Question number 111. Identify the incorrect statement. Option 1. The transition metals and their compounds are known for their catalytic activity due to their ability to adapt multiple oxidation states and to form complexes. Option 2. Interstitial compounds are those that are formed when small atoms like hydrogen, carbon, nitrogen are trapped inside the crystal lattice of metals. Option 3. The oxidation state of chromium in CrO2- and Cr2SO2 2 minus are not the same. Option 4. Cr2 plus D4 system is stronger reducing agent than Fe2 plus D6 system in water. If you know the structure of molecular ion, you can calculate the oxidation number in this process. Each bond contributes +1 to electropositive element and -1 to electronegative element. In Cr2 minus, there are 6 bonds with oxygen. Therefore, the oxidation number of chromium in Cr2 minus is +6. And look at the structure of Cr2SO2 minus. There are 2 central chromium atoms. Each chromium atom is bonded to oxygen with 6 bonds. 1, 2, 3, 4, 5 and 6. 1, 2, 3, 4, 5 and 6. So, the oxidation state of each chromium atom in Cr2SO2 minus is also +6. Therefore, the oxidation state of chromium in Cr2 minus and Cr2SO2 minus are the same. Another process is like this. Let us consider the oxidation number of chromium is X. For Cr2 minus, we can write the equation X plus 4 into -2 equals to minus the charge of Cr2 minus is -2. Therefore, X equals to -2 plus 8 equals to +6. Similarly, for Cr2SO2 minus ion, we can write the equation 2 into X plus 7 into -2 equals to -2, as the charge of Cr2SO2 minus ion is -2. 2x equals to -2 plus 14. 2x equals to plus 12. X equals to +6. Therefore, the oxidation state of chromium in Cr2 minus and Cr2SO2 minus are the same. Therefore, statement 3 is incorrect. Therefore, the correct option is option number 3. Question number 112. Which of the following is a cationic detergent? Option number 1, sodium stearate. Option number 2, cetrimethyle ammonium bromide. Option number 3, sodium dodecyl benzene sulfonate. Option number 4, sodium lauryl sulfate. Look at the structure of sodium stearate. This is an anionic detergent because this part is anionic. Look at the structure of cetrimethyle ammonium bromide. This part is cationic. And look at the structure of sodium dodecyl benzene sulfonate. This part is anionic. And look at the structure of sodium lauryl sulfate. This part is anionic. So, this compound, and this compound, all three are anionic detergent. But this cetrimethyle ammonium bromide is cationic detergent. So the right option is here, option number 2. Question number 113. The freezing point depression constant Kf of benzene is 5.12 Kelvin kg mole inverse. The freezing point depression for the solution of molality 0.078 m containing a non-electrolyte solute in benzene is rounded up to 2 decimal places. Option number 1 is 0.80 Kelvin, option number 2 0.40 Kelvin, option number 3 0.60 Kelvin, and option number 4 0.20 Kelvin. We know the depression of freezing point LTF equals to Kf into M, where Kf equals to freezing point depression constant and M molarity of the solution. Equals to K was given 5.12 Kelvin kg mole inverse into 0.078 kg per mole equals to 0.39936 equals to 0.40 rounded up to 2 decimal. Therefore, the correct option is option number 2 here. Question number 114. Identify the incorrect match. Name against IPC official name. A. Anium 1. Mendelevium. B. Anilin-trium 2. Lawrencium. C. Anilin-hexium 3. Seaborgium. D. Ananium 4. Darmstadtium. 1. B2 2. C3 3. D4 and 4. A1. The IUPAC official name of ananium, atomic number 111, is Roentgenium. So the correct option is option number 3 here. Question number 115. The mixture which shows positive deviation from Raoult's law is option 1 benzene plus toluene, option 2 acetone plus chloroform, option 3 chloroethane plus bromoethane, option 4 ethanol plus acetone. In pure ethanol, its molecules are hydrogen bonded, but in acetone, only dipole-dipole attraction exists within the molecules. On adding acetone, its molecules enter into the intermolecular gaps between ethanol molecules and break some of the hydrogen bonds. As a result, total vapor pressure becomes more than that calculated from Raoult's law. So the mixture shows positive deviation from Raoult's law. So the correct option is ethanol plus acetone, that is option number 4. Question number 116. Match the following. One column is oxide and another column is nature. A. Carbon monoxide 1. Basic. B. Barium oxide 2. Neutral. C. Al2O3 3. Acid. D. Cl2O7 4. Amphoteric. Which of the following is correct option? A, B, C, D given 1, 2, 1, 4, 3, 2, 3, 4, 1, 2, 3, 4, 3, 2, 1, 4, 1, 2, 3, 4. Look at the two columns. We know carbon monoxide is neutral. Al2O3 is amphoteric. We know Cl2O7 is acidic and barium oxide basic. Therefore, A2 is here, B1 is here, C4 is here, and D3 is here. Therefore, the correct option is option number 1. This is the correct option. Question number 170. Which one of the following has maximum number of atoms? 1. 1 gram magnesium solid. Atomic mass of magnesium Mg equals to 24. Option 2. 1 gram oxygen gas. Atomic mass O equals to 16. Option 3. 1 gram lithium solid. Atomic mass Li equals to 7. Option 4. 1 gram silver solid. Atomic mass Ag equals to 108. Consider NaH Avogadro number. Therefore, number of magnesium atoms equals to 1 by 24 into Avogadro number. Number of oxygen atoms equals to 1 by 32 into 2 into Na. Number of lithium atoms equals to 1 by 7 into Avogadro number. And similarly, number of silver atoms equals to 1 divided by 108 into Avogadro. Look at the four values. The maximum value is the number of atoms this is the right option. Therefore, the correct answer is option number 3. Question number 118. Reaction between benzaldehyde and acetophenone in presence of dilute NaOH is known as option 1 Canniger reaction, option 2 cross Canniger reaction, option 3 cross aldol condensation, and option 4 aldol condensation. You know the structure of benzaldehyde. And the structure of acetophenone. This molecule contains no alpha hydrogen. These hydrogens are alpha hydrogens. A carbonic compound which contains no alpha hydrogen take part in Canniger reaction. And a carbonic compound containing alpha hydrogen atom can take part in aldol condensation. We know alpha hydrogen containing carbonic compounds can take part in aldol condensation because it can generate the carbanion OH minus from NaOH takes the proton. Gives rise to carbon ion. This carbon ion can attack nucleophilic center of same carbonyl compound or other carbonyl compound. But we know benzyl diarrhea is more reactive than acetophenol. So this carbon ion will attack on this carbon. Carbon will attack on this carbon. The pi bond will break towards oxygen. Then it will generate proton from water. After the nucleophilic attack, an aldol type compound will be formed. Water will be eliminated by dehydration. And the final product will be as it is occurred between two different carbonyl compounds, that is benzaldehyde and acetophenone. So it is a crossed aldol condensation. That means the right option is option number 3. This is the right option.